Wow.
Yeah. I mean, they didn't even touch each other, but you can see she's, I don't know if you can see that from there.
No, not very well. So
Yeah.
feel free to.
So she's reaching down to pet him,
Yeah.
and I'm right here. I'm not really seeing the whole thing, getting ready to focus another one, and then I heard this, and then I saw this. She's leaping back, and the cow was rearing up.
It's got some horns.
Oh yeah,
Yeah.
We keep calling it a cow. It's actually a bull. That's a bull.
Sometimes buffaloes are also.
Yeah. So, and this was only one. We saw 2 or 3, and one time we saw a pack of like 10 or 12. Yeah, they just ruled the streets.
All right, I'm gonna start the bush here. Thanks.
Thank you.
All right. I think we'll get going because we've got a fairly full agenda, and we've also got somebody supposedly joining us remotely who didn't want to stay up all night. So we'll get going here. So good morning, everybody. I'm Al Morton. I'm one of the co-chairs of the Benchmarking Methodology Working Group. That's the session you're in this morning. My co-chair, Sarah Banks, is unable to join us. And I don't see her on remote access yet, but I see our sort of our second presenter has joined us via Meetecho, so that's going to work out great, timing wise. So if you're new to Bmwg and you'd like to join the working group, especially the mailing list, there's a link right here in the first slide, and you can go there and join it quickly. Who's new to Bmwg? Raise your hands. 4 or 5 people. That's great. So this working group is a little different from all the others that you might attend here in IETF week. Although sort of at the end of the week now, but you'll probably see this quickly. If you have a testing background and you have an interest in testing network devices, whether they're physical or now, the hot thing in our world now is virtualized network device testing. It's very easy to join this group. Read some drafts, make comments on the mailing list, and you'll be one of us before you know it. And when you read a draft, you'll find that there's usually the fundamental references are pointed out for you right in there. And RFC 2544, 2889, those are some of the key ones. Those are the ones we're actually looking at improving in the future. You'll see some of that work today. So welcome to the group, those of you who haven't attended before, and those of you who have, welcome back. All right, so let's get going here. This thing, I can go to full screen actually, here we go. And I can use the clicker as well. So here's the note well. One of our rules is basically that any contribution you make at the microphone or anything you say at the microphone is a contribution. It's subject to our IPR disclosure rules. If you have IPR in something that you're presenting today, please disclose that. If you have any questions or you want more details, you can talk to me or you can read any one of the, I guess that's 6 BCPs there. So there's plenty of information about our IPR disclosure process. So here's our agenda. The blue sheets are going around. Please sign it, especially today, because we have seemingly a smallish group starting out. We're not going to do Jabber today. I've offered people other ways to join us, and we've had some trouble with that as well. Okay, the blue sheets are going around. I've mentioned IPR, and so now we're going to bash the agenda. First is working group status, and then the milestones. That's great. Thanks, bro. And let's see. We had a little interaction with the. Here we go. We'll keep this out in the audience so you guys can hand it around. We had a little interaction with the ETSI NFV test working group in terms of a liaison over the last few months, and I'll just quickly mention that they've reached a publication on their standard. And then we're going to have a benchmarking methodology for network security device performance presentation from Samaresh Nair, who's joined us. He's going to be making this presentation remotely. Thank you for doing that, Samresh. Then we plan to go into the EVPN topics, of which there are 3. Sudeen's going to present 2 of them, the working group draft and the new proposed draft. And then I'm going to briefly present the 3rd one that's there with a long title. So we'll cover EVPN all together. Then we're going to look at a couple of continuing proposals, the updates to the back-to-back frame benchmark, and one of our colleagues, Yoshiaki Ito, has been doing some work in this area, and so he's very prolific in his lab testing and has shared a few slides with us. He's unable to join us, but I'll share the slides and get your feedback on that. We have a couple of.
I think he's just testing.
Oh, okay.
According to the Jabber.
Okay, that's good. That's good. Because we're coming up to you, Samresh. Very good. So let's see here. Yes. So then we got to the new proposals, which are actually going to be presented by Mr. Oleg Tron, who's here in the front. Masiek and Vratko are the authors, but neither one of them could make it at this horrendous hour for European time zone. So Oleg is here to stand in, and much appreciated, Oleg. The last topic is liaison from ITUT Study Group 12, which was actually sent to the IPPM working group, but there's overlap in the work that I described there and with our work here. So I've decided to spend a few minutes on that, and I think it will be useful for us, assuming we have time. If there's time, we may have other topics brought up, maybe some new proposals and so forth. Thanks for joining us, Ignace. I was about to mention that Warren is a bit under the weather today with an unfortunate culinary choice, apparently, and that can happen to any of us, in truth.
So I'm pretending to be Warren and something. I mean, in sort of small, yes.
It's okay. It's okay. We're very, as I just got done saying to the 5 or 6 new folks who have joined us, we're very welcoming to new people, and among the ADs, you're very welcome. So thanks for standing in for Warren. I'm sure he appreciates it. Okay, so we've got to the point where folks can go to the microphone and bash the agenda, or simply sit quietly, and the chairman will say the agenda is approved, and we'll move on. Thank you. Let's just do that. So we're heading into the working group status now. We've completed 2 RFCs, the SDN controller drafts on terminology and methodology. We've got a whole list of proposals that keep coming. You're going to hear about most of them today. Industry discussion topics are in the area of buffer size, search algorithms, traffic generation calibration, and here he comes. We'll need you to sign in too, So these are our, this is our sort of our quick status, new RFCs and lots of proposals. I mentioned that we've also got this liaison relationship going, although we looked at this draft through a couple of meetings and we didn't prepare any comments on it. That's okay. But now it's been published, and I'm actually using it as a reference in one of my drafts. So I encourage people to take a look at this. There's a link to the document in the basically in the agenda, the text version of the agenda online. And so I encourage you to look at that. It's essentially RFC 2544, our throughput and latency and some other benchmarks tuned up for the new world of network function virtualization. We learned a lot of things that we had to improve in order to make that work more reliable, especially about search algorithms. And there we have really documented some new things based on testing. A lot of collaboration between the FDIO, CSIT, the systems integration testing at the FDIO project. That's the VPP form of vSwitch, vector packet processing. And Also the OPNFV, VS-Perf, and NFV bench projects. So a lot of collaboration here between ETSI and those groups. We have collaboration going on with OPNFV and soon FDIO CSIT as well. So there's a nice community developing here of folks testing, folks writing specifications, and a feedback loop where we're improving everything based on what we all find. So here's our current milestones. We got one in red, but we've got, this is the one for next-gen firewalls. It's currently in working group adoption. So I encourage you to take a look at that. Actually, I think the adoption call ends today. We've had some good feedback on that on the list. We'll be looking for more feedback here today in the meeting. Everything else is in, well, precarious shape because we haven't adopted any of the other ones except for the EVPN benchmarking draft there. That's the third one in the list is adopted. We'll hear about that today, and maybe we can move that along as well. Let's see what the group feels about that. So anyway, we may be updating some of these milestones after we take a look. So I mentioned the SDN controller terms and methodology. That's RFC 8455 and 8456. Pretty good numbers, pretty easy to remember. And these drafts really got a lot of comments in the sort of the IESG last call and the IETF last call and IESG review. Took a while to get them through, but they are now through that now. And also RFC editor had a lot of comments too. So congratulations to the authors. It's a long list of authors, but we're now effectively done with those, and that's published. So very good work. We're done with our charter update, and we have a supplementary web page, and you're welcome to take a look at that. There's some advice there on how to join the working group quickly. Our work proposal summary matrix is it's actually sort of gone beyond the bounds of one slide. I haven't even tried to update it with the new proposals that arrived in this context. And what that means is we're going to look hard at the ones that are here and say, is this really still alive? I'm kind of doubting that SFC is still alive. Back-to-back frame is there. Next-gen firewalls is there. The VNF proposal, we haven't heard from that in a while. We'll see. So, I mean, there's going to be a little cleaning house on this proposal in the tracking, and I think that's worthwhile to do. So, if you're writing if you're writing a document for our group, we have this security paragraph, which we like people to at least consider for. Is this on? No. At least consider for Wuxi. In fact, we'll just leave this in the back, and you're the guy who points it to the next guy who comes in. Come on up.
Thank you.
Thank you. Welcome. So the main purpose of this paragraph, set of paragraphs really, is to inform folks who read our drafts at IETF last call that this is a working group that has a laboratory-only scope. So the kinds of things that we do that absolutely saturate, 10 gig or 40 gig links, they're not going to have operational implications or security implications. And once people read these paragraphs in our security section, they usually figure out that that's the case. Otherwise, a lot of reviewers pick up our drafts and have no idea what our charter is. So it's been helpful, very helpful. So that's it. Any comments on the working group status? Okay, very good. So let's move on to the next presentation. And let's see, it's this one. And all right. So Samaresh, you're going to want to join the queue, and then I'm going to great, And then I'm going to press a big red button, and then we should be able to hear your voice.
Yes,
If you-
hear me?
Yes, we can hear you perfectly. This is working great. So the only trick then, Samaresh, is that you're going to have to tell me when to advance the slides, which I will happily do.
Sure. Should I start it? Are you able to hear me?
I missed a little bit of what you said there, but I've just advanced to the next slide.
Can you hear me?
Yes, we can hear you.
All right, we can just go to the first slide. I just want to start with a little bit of introductions, and then we'll go to the second slide.
Okay.
So, good morning to everybody. I hope you're all enjoying there in Bangkok. Sorry, I'm not there. I would have much rather actually liked to be there. So I'm here to present the draft standard for NetSec Open and present on the current status as it stands, and dwell a little bit on what we're doing at NetSec Open. And my name is Samaresh Anir. I'm a senior product manager working with Palo Alto Networks. I'm one of the contributors towards NetSec Open Forum. And I'll be happy to present the current statuses and take any questions if you have. Well, next slide, please.
Okay.
All right, so currently the status is currently a draft standard, and we are in version 5 currently. With version 4, we have done some extensive reviews, and some of the sections number 1 to 4 have been reviewed, and we will be presenting an update after the IETF 103. The proof of concept testing with this new version has already started, and thanks Al. Al has called for an adoption for this version already. Next slide, please. So I want to dwell a little bit on what exactly is going on in in proof of concept testing. So we start off by configuring the DOT. Now, obviously, the whole project is aimed at testing next generation firewall performance tests. So what we want to make sure is that first, the security inspection functions on the DOT is turned on. So unlike what was done sometimes earlier, where the performance testing was done with no security no security inspection turned on, the objective over here is to make sure that the security inspection is turned on a DOT. Sorry for typo, but yeah, we need to make sure that the logging is turned on because we expect the customers should have the logging enabled on their devices. Once the configuration on DOT is done, the configuration is pretty much locked down and cannot be changed until the end of the testing. We do not want to allow any changes in the configurations. Next slide, yeah. So the second step is we have actually done a filter of the CVE list, which is basically the vulnerabilities that we want to run through the device. And the criteria that we have used is basically high severity, which is CVSS score 7 to 10. And we've taken the CVE list from 2010 to 18. That's really what we consider is relevant and anything earlier than that probably is not relevant now. So with all of those, we have about 1,200 lists of CVEs that were considered. And we also are using a couple of test tools. So we want to make sure that the test tools itself are able to run those CVEs. So we filtered out further, and we have 430 CVEs that we are using for proof of concept testing right now. Out of those, we have actually split it into two. First is 400 CVEs are what we call as a public list, and that is shared with all the vendors which are participating right now. So we are basically giving it, it's like an open book. We're giving it away. Okay, these are all the CVEs that we'll be testing. We want to make sure that all those CVEs are detected by the security device. The 30 of them is kind of a secret list that is kept aside, not shared with the vendors. The idea is that the vendors should not be cheating in the test. So with a public list, we're giving away all the details. With 30, and we want to make sure that the vendors are not kind of trying to work around by just having coverage only for those, and trying to kind of call it cheat the system with only those. So we have another 30 which are kind of secret, will not be shared with the vendors, and we want to make sure that those are detected by the device as well. Next slide, please. So once all the when we run the test for security, make sure that all of those CVEs are detected. The main test starts, and in terms of the testing, right now we are looking at all these tests that you see on the screen. So basically, these are a bunch of throughput tests and session scale and capacity tests, TCP, CPS, and HTTP transaction per seconds and things like that. A whole bunch of tests, as you can see on the screen. Give it a moment. All right. So those are all the tests that are that will be tested. And what are we actually trying to achieve with this? The first is, this is a proof of concept testing, which means the test vendors, the test tools have actually created certain profiles to be able to use this NetSec Open Forum, NetSec Open Draft Standard. We want to make sure that the test tools are actually able to do that, which means the test tool is kind of ready for the testing. We want to run through it and see if there are any changes, any adjustments that we need to make. Because as we go ahead, we might end up finding some issues, and we might have to make some adjustments. So we'll actually look at it, and we'll actually gather details and feedback from the folks who are involved in this. And if there are any changes to be done, we will make those changes. We also want to make sure that we have all logistically everything set up, which means the test tools, test vendors, everybody is able to run through this test. We want to make sure that practically there are no issues in running the test. So in this whole exercise, there are a few players. So first of all, there are 3 labs who are actually participating in this: ENTC, UL, and UNIOL. These are 3 labs, and the 3 labs are mainly using 2 different test tools, mainly Exia and Spartan. These are the major test tools that are used for performance testing of network security or NG firewall kind of devices. And currently 5 security product vendors, including ourselves, Palo Alto Networks, is also participating in this. Next slide, please.
Okay.
So in terms of timeline, the proof of concept testing is currently in progress. I think we are kind of halfway through for many of the vendors as well already. So idea is to, our objective is to end the proof of concept testing by end of November. We want to make sure that we review them, and we'll make some adjustments if necessary. And then we should have an updated draft around early December. And we'll submit the updated draft to benchmark working group early December, once ready. In terms of the results, so since this is just sort of a proof of concept testing, it's not like a public test, so we do not want to actually publish these results. It's kind of confidential, and that's why we're not publishing the results as such. And that's kind of requested by test participant. And then there are certain differences between test tools that have been identified. So Ixia, Spartan, they work a little bit differently. So we have looked at all of those, and there are certain differences that are found, and we're looking at making sure that the overall objective is still met regardless of the differences. And of course, the goal is to make sure that there's a whole documentation and available to all the participants when we are ready for the prime time. Next slide, please. Okay. So, given all this, this is our request to benchmark working group. We need your help to move forward with this. We want you to commit, requesting you to commit to the mailing list to review this draft. I guess that's the final slide.
Very good. Well, thanks, Samaresh. I would like to open the floor to folks from the working group assembled here today. If you'd like to offer support for this work now verbally at the microphone, or comments on the draft if you've had a chance to read it. I've already put a whole series of comments on the mailing list for this, and we've seen some support. I think 5 or 6 people, something like that, on the mailing list. But now is a chance to express it sort of additionally here live, and where you can provide some feedback right away. Okay, thanks, Sudin. Sudin Jacob put up his hand and said he supports the work. Okay. Anybody else? Any comments on the draft? It's a pretty big draft, actually. Yeah. So, okay. Well, I'll be considering this topic with my co-chair, of course. Sarah hasn't joined us yet, but hopefully she'll join us during the session. And then we'll consider the results of the call for adoption and let the working group know. Samaresh, a question I had, since no one's rushing to the microphone here. The proof of concept testing. It seems to me that if there's something specific that you learn from the testing programs, maybe something that affects the procedures in the draft that you've got right now. I wonder if there wouldn't be possible in some anonymized way to share some of the results of that testing with us here in Bmwg, and make for a little more compelling case for revising the draft. Any chance that would be possible?
Sure. Also, if I understand right, you're looking up for what is the feedback which is received during the proof of concept testing, and see if we shared. So as I mentioned, right, we are currently at revision 5, and based on the feedback that we get during the proof of concept. Based on the feedback, we will update it. And send it to the working group.
Very good. It sounds like I stressed your voice one question too many there, Samaresh.
Sorry, your question was very hard for me. I couldn't digest it. I'm sorry. So I'm back. Yeah. So yeah, we will be reviewing all the lists, and based on the issues found any, we will update the draft, and we will provide you with the changes that are made between the previous draft and the new draft. And to your request on the anonymized feedback, I'll let Brian Monkman, who's leading this effort, comment on that, on the procedure part, but hopefully that should not be a problem.
Very good. Thanks very much. Any final comments before we let Samaresh go? Okay, I think we've got what we need here, Samaresh. I thank you for making this presentation remotely. Much appreciated, and we'll proceed with the working group business on your draft and the others. Thank you.
Thank you very much.
Okay. All right. So on to the next. So this is going to be Sudin. Come on up, Sudin. Doug, are you prepared to take any notes? Oh, okay. Well, I'll try to do it while you're up here, Sudin. Yeah, good. All right. Okay. So let's see here. I press this button, and then I give this to you, and it sounds like that is on. So this is the working group draft on EVPN benchmarking. Both the both PBB and regular EVP. And please go ahead. Please go ahead.
Good morning, Al. Good morning, everyone. This is a draft about benchmarking EVPN and PBB EVPN technologies. Oops. Oh, okay. Yeah, EVPN, which is defined in the RFC 7432 and the PBB EVPN 7623. The EVPN is widely deployed, and this is in the BEST working group, which is actively participating the different variants of EVPN. So initially the pilot draft, which was you can say the container or the mother draft, as it was 7432. From there, various drafts like EVPN, VPWS, then FXE, a lot of things are there. So it was deployed in different provider network. So we provided a set of parameters for benchmarking these services. Before that, the previous the comments. So the topology expansion, there was a comments from the last IETF, then test case details, and details of the environment, and inclusion of EVP and VPWS benchmarking. Then we had a discussion with the different test teams, and because we cannot compare EVPN and VPWS because it's not apples to apples comparison. So we floated another draft because it was a need coming from the community. So we floated another draft. So we discussed with the chair and we discussed with the test folks and said that we cannot include in that because it's a ELAN and another is a E-line. So both are the different things, so we can't do it. So we float a different draft on it. So these are the comments. And these are the basic parameters we have defined to benchmark the EVPN services. That is the MAC learning, that's a local as well as the remote. Because EVPN, you know that the MACs, which is learned local, will be advertised via the BGP. So the different, the learning, we have MAC learning in the local and remote, then MAC flash, then the MAC aging, then high availability, then ARP scaling, then the scale with convergence, how fast it is convergence, and to avoid the flood in the network, because the flood is very dangerous and because it's going to choking the bandwidth. So these are all then the convergence that's a common test, the convergence test, and SOAK and high availability. It's just high availability is just a failover test to see ideal case is a 0 packet loss, but there will be some packet loss will be there when you do the routing engine failover. Then the SOAK test, which will be running over a period of time. So either 24 to 48 hours. Normally it is 48 hours will be running it, so that no course, nothing should be available. Yeah, questions?
Hey, Barak, may I just ask a little question about the scope? Do you intend to test control plane, data plane? I'm not sure I get it.
Yeah, this is as a service, it will be testing both the control and the data plane. Data plane is the RFC, as Hal mentioned, 28 that the data plane learning rate, as well as the control plane BGP advertised to that. That is where the MAC learning through the remote. So the MAC learning is the first parameter which checks the local learning as well as the remote learning. Both will be covered because the BGP takes the serialization delay. It advertises as a type 2 routes to the DUT. So the MAX, which is learned from the remote router, it will be advertised to the DUT as a BGP advertisement, then LRA type 2 and LRA. So that is also considered because EVPN comprises of both. So in the MAC learning parameter, it is taken care of the both.
Okay, maybe I'll wait for the...
Yeah, you can go through and give the comments. Thank you. So thanks to Sarah and Al. Sarah was guiding me all through this journey for the past 1 year. So thanks, Al, for the support. So next step, Al.
Oh, yes. So thank you, Sadine, for the posting the update and for your quick summary here. I think we've got some. I think there's some possibility that we could maybe take this to a working group last call.
Okay.
So let me make an action for the chairs there. You can't pick this up, can you? Oh, all right. Oh, all right. And I guess before we before we cut off the discussion here, any other comments on the draft? Who's read it in the room? Looks like one person. Very good. Okay.
Thank you.
Well, I've read this too.
Thank you.
I should put up my hand. But if there's any additional comments folks would like to make now, we can do that. Otherwise, I'd invite some of the new folks who are interested in this technology to read the draft and provide comments during working group last call. In Bmwg, sometimes we have several working group last calls to kind of stir up the comments. So that's happened in the past.
Yes,
I'm
please.
sorry that I haven't read the draft before. Did you include both layer 2, layer 3 advertisements?
Type 3 advertisement, because type 3 is just a flood. That is
Layer 2, layer 3. I like both max and prefixes and
prefixes. Yes, ARP
host
scaling.
routes.
Yeah, ARP scaling is there because the MAC plus IP.
Not only ARP, right? Prefixes.
Yeah, type 5 is not. Type 5 because it's a separate draft. That's a type 5 route as itself is not part of EVPN RFC. So that is not added. But MAC plus IP, that is the ARP and the IPv6, MAC plus IPv6, that is covered because it's one of the parameters, the scaling of that. It is covered that.
I see. So at least from my perspective, I would suggest to add type 5 as well.
Type 5 was asked, in earlier also. Then it was a big discussion because the type 5 then with the authors also they said one of the author of the RFC 2432 Jim also said why you add because it's a separate one. It's the prefixes which is gone at that. It is a separate one. So why it is needed in this? So that is the reason initially we added in, I think in the version 6 or that. Then after we pulled out from one of the authors of the draft, Jim, then that's why we pulled out. Initially the comment came in one of the IETF to add that type 5 scaling. So that's why we made a generic parameter, even though a type 5 is coming as an as an advertisement, even MAC plus IP is there. So that scaling will automatically be covering that.
I tend to disagree.
Okay.
Because, I'm coming from the implementation perspective. It's very different. It could be very different.
Yes. Yes, I know that.
And to be honest, I guess type 5 is one of the most important things. Mac is nice, but we move forward. So I think it's kind of not full enough if you don't include both type 5 and maybe even consider 6 to 8.
Sorry, I didn't get you.
Maybe consider type 6.
Type 6 because that's a multicast route because it's still in the draft phase that we could not. Type 5, let me see that because already we cover a generic as I agree with you. Already we included, then we excluded after the comments from the author along with Ali. So I will work to it to reach a middle ground on that. That I promise you. But type 6, no, because that's a multicast one. This is purely on on the RFC 7432 because that is the scope is defined. So that's why we could not go beyond that boxing parameters.
So you plan to have another one?
Another one, if the demand is there, we will definitely because SMET and all those things are coming up. It's slowly deploying in the network. So we also see, I'm observing the market. So because a couple of deployments have come on that, but if it is the need, definitely I'll float a new draft on that.
All right, and 2 more questions, if I may. Do you refer both for MPLS data plane and for IP data plane? Underlay?
I'm sorry?
From underlay perspective, how did you define that?
This is EVPN, benchmarking. It is for MPLS is currently defined that the DUT and all. So the same parameters you can apply for IP because the EVPN doesn't change. Only the underlay changes like VXLAN.
Right.
So now I think Geneve is also coming up. So irrespective of we defined the parameter irrespective of the underlay. So now we tested in our lab with MPLS. We can have VXLAN also. The same thing works fine. So we have tested that too. But now Geneve is also coming. So it's in the draft phase. I checked with the author. He was telling it is going to come as RFC.
Right.
So this, so it's like it's like a container. The overlay it's like container. You keep the payload. So what is a payload? how we are going to define that payload, that is what we are defining here.
I see.
So irrespective of the container, you can have a EVPN as MPLS as a container, or you can use as a transport overlay as a VXLAN, or tomorrow Geneve is coming.
Okay, so I think like from an implementation perspective, I think
I agree with you.
I think there are also a lot of knobs you might want to consider in your draft, and it has to do with how the underlay is configured. Let's say how many next stops I have in the underlay might affect the overlay performance. So I think it's not, from architecture perspective, yeah, you're definitely right that overlay, you can discuss overlay without know what the underlay is. Unfortunately, when you go to the lab, it matters. So
yeah, I understand, because I have done both the deployments, because that's why we have to box in, because this RFC. So if you are because the underlay, if you're gonna, it will be very big. So the type 5 we will try to squeeze in into this.
Right.
We'll see, because there was a lot of discussion, I think in Chicago or I think Seoul. So this was a discussion which was asking. Then the Jim was one of, as I said earlier, he was the co-author of the RFC 7432. So he said that's why we pulled it. So we made it generic as ARP and ND scaling. So this I will consider it. I take it positively. The SMAT issues and type 6, we will float as a new draft, because currently this is beyond the scope of 7432, as you are aware, right? In the best work group, it's still going as a draft. So that we will consider as a new draft. Once let me observe this. Thanks for the.
Thank you so much.
Yeah.
Thanks for the great comments and adding your obviously very relevant.
It was very nice. I mean,
So it's type 6, and what else is going to be considered for a new draft?
Type 6 and 7 is also, because I'm not aware of the multicasting 7, because they have defined new draft for the multicast.
Oh, okay.
So in that draft, we can EVPN 2 type routes. Like in normal 7432, only 4 routes are there, 1, 2, 3, and 4. Then they added type 5 in a separate one and prefix, and this for the multicast.
Okay. You guys made me work hard there. I'm supposed to be the chair, listening and enjoying these discussions. Here I am taking all these notes.
Yeah, I love to get the deployment, because I always follow the deployments, and based on their inputs only, because that's how, you have to have apples to apples comparison. So how do you gonna, box in the certain things, and you plug in your RT and test and get it, hey, this is giving you this much and this is having this much. So as a provider, as an implementer, you will get the benefit. So I'm fitting my legs on your shoes and seeing that. Thanks for wonderful comments. This type 5, I'll take it to that. Type 6 and 7, I'll go back to the lab and see that, because I never tested on that. I'm just observing the things which is going in the market.
Very good. All
Yeah.
right. So and I think I'm going to mark this as Sarah and I will talk about this anyway.
Sorry, which?
I'm sorry, Sarah and I will talk about this anyway for the possibility of starting a working group last call.
Okay, thank you. So this is the next draft of the EVPN VPWS, because the last IETF, the last IETF in Montreal. So one of the co-author of the 7432 Jim asked to, as one of the comments which I mentioned that, right, to incorporate this into the draft. Then I said it, and I test with, I have concurrence with the community as well as the chair, and I said, because it's not an apple-to-apple comparison. So this is the reason we float a new draft on this, to how to benchmark EVPN VPWS. So EVPN VPWS is a currently new RFC. It's a 8214. And this is one of, we can say, a lot of benefits in this particular RFC, because in this VPWS has been in the Metro Cloud for a long time and in the service provider for a long time. One of the basic drawback of VPWS is there is no active forwarding. So one will be your active forwarding and another will be hot standby. So you cannot use, as an implementer or as a customer, you cannot use both the links for forwarding. So that is what's one drawback, and you cannot have both the links utilized, and these are all the kind of problems which are faced. Then once the EVPN came, it was one of the kind of a mothership, and a lot of other things which started gluing into it. It starts growing and growing and growing. So now it becomes most of the providers, they have adopted this EVPN technologies, and most of the conventional which were using the legacy systems are now coming into the EVPN. So the BESS is working a lot of things on this. So I request to a lot of the developments which is asking, I request community to just have a tab on, if you're interested in this technology, keep tab exclusively on the BESS working group. So as I said, and this is one of the load balancing capability you can utilize from the remote PE. Also, you can send the traffic to the same the customer site. Based on the multi-homing features, you can send it, and a lot of benefits which gives advantages to the customer, and it will reduce the OPEX. So otherwise, it'll be wasting one link unnecessary, and you are wasting your dollars. So to avoid that, this is one of the capability. You use both the links, so you get the benefit of it. That is a VPWS draft. It's a relatively 16-page RFC. It's a pretty good one. So we defined a certain parameters. Since it is a E-line service, it doesn't have the learning capability. What all comes in, take it through the pipe and send it out. So we cannot have the learning. That was one of the challenge. We cannot have a learning, MAC learning or anything in the service provider edge router. What all comes in, just take it and put it into that. It's like a pipe. So how do we, that was a challenge when we were testing in the lab. So how do we benchmark this? How do we performance monitor this particular service and between the different boxes? I mean, say for X vendor, Y vendor, Z vendor. So these are the certain parameters when we test it. Okay, you jot down on it, and we see, okay, generalize certain parameters on this. This is one of the local link failure. So the link failure in which how fast, that is in a multi-homing scenario, how fast it will switch from the one PE to another. So it depends on the the routers, routers to routers. So the timing. So we are taking the average of they repeat the test and get an average on it. Then the core link failure. So that how fast the remote PE will switch switch that to the earlier primary to the new primary, and how fast it is coming up to avoid the packet loss. Then the link goes up and down, and how fast the DUT takes, because these are all tested based on the single active, because in active there is no DF election. So it's both will be the forwarding, but in single active, you have the primary and the backup concept. So this test is purely, if you go through the draft, test is purely done on single active scenarios. So the link flap, what happens is like when you flap the link, once the primary goes down and it goes, the backup becomes the primary, then it comes up, then again the re-election takes place, and again the primary kicks in. So there will be a gap if either you have a preference-based DF election or a VMOR then. So there will be some packet loss. So how fast it is converging, that is we are measuring it. Then normally in VPWS, one thing is like adding the services. In service provider, you add the services, like say 15 customers, you add it, or 150 customers, automate testing, like writing scripts and adding it, and deactivating. If they didn't pay the bills, you deactivate it. This is automated testing. So you deactivate the customers, and once they pay, you activate it, so that the services, expectation is services should come up, the packet should flow, and the existing services should not be affected. And the scale convergence is you scale up to what all the number is. We are not defining that number, and scale it, and you flap the link and see how fast it is converging, because the scale varies between the vendor to vendor, and how the packets are processed, the hardware and all, it matters. Then high availability, it's the common test in the Bmwg. You fail over the routing engine. So it will be running at non-stop forwarding. So you flap it or you reboot the primary routing engine, so the other routing engine takes up. So ideal case is 0, because ideal is ideal 1, and practically you will see a few packet drops. So that is the SOAK is running the full-blown system with traffic in a multi-dimension scale, running over a period of 24 to 48 hours, and expectation is no core, no crashes, no memory leaks. So we have automated tools to check that if it will poll frequently every hour what is the status, and gives us the result at end of that. So thanks Alan, Sarah, for the support. So next step, please comment it. This is the first draft, I mean the 00 version of the draft. So please feel free to read it, comment it,
Anybody read this yet? Ignas has. That's pretty good.
So, so I request folks, because since EVPN is deployed and you may be testing it, if you are from the test community, you will be testing different services or a service implementer or providers to the end customers. Please.
I have a question.
Yeah, please.
Is the soak test the only one with data plane traffic?
No, scale and convergence is also with scale convergence, deactivating all this with traffic.
Okay.
Because without traffic, there is no point in testing. So that is the where.
So you're actually checking the restoration in the data plane.
Correct.
Yeah. Good. Okay.
Yeah, please.
Question: when you consider scale and as part of these drafts, do you consider the amount of peers you have to work with?
And it is the currently, because it's a test setup, I have only one peer. So if you have with one peer we have tested it. So it is it's a test setup, right? So with one peer, I have two multi-homing P which are acting as the same Ethernet segment, and I have one single home P which has a remote in single home PE and one route reflector. If you look into draft, there are three topologies mentioned. So, and the traffic direction. One will be testing with the traffic from going from north to south, then north to south and south to north, and bidirectional traffic, various tests.
I see. I can tell you that from my perspective, it's very important to test scalability versus amount of peers and amount of VNIs.
Okay.
It's super important. At least I think we come from slightly different point of views, which is good. I'm coming a little bit more from the EVPN in the data centers rather than providers. And there is a real pain and questions about the scalability in terms of amount of peers, amount of underlay destinations that you might need to reach out to, and amount of VNI supported.
But BPWS, RFCs.
No, I'm talking. Probably it's more important for the previous one.
Yeah, previous one. Yeah, that.
Who's got the blue sheets?
Yeah,
it's got to be in the back there someplace, Bill. Yes. Sorry for the interruption.
Oh, no problem. So in the current scenario, because if you have the RT or the router tester like Ixia or Spirent, this should support that many peers. I think EVPN VXLAN Ixia supports. We can automatically synthesize the number of peers, but in MPLS, when you generalize, right? So we need a physical box. So that's why we box in the topo to like this. So EVP now, I think the latest Ixia IX network version, they have the synthesizer. You can have the number of peers, and they support the VXLAN payload. Earlier, when we started the draft, nothing was available. So we have to define the things.
I see.
So that's why I said earlier in draft also. So when we have to have, so we left the container as such, we take the payload, and so we shaped on that and we work boxing on that.
But are these parameters for your testing?
I'm sorry?
Are these kind of things parameters for your test benchmark?
Number of peers.
Number of peers, number of VNIs, number of VRFs, all these kind of things.
And VRF, it is there. It's part of VRFs, and VRFs is number of it. That's a scale convergence. Yeah. It is part of that.
So VNIs as well?
Yeah, that is VNI. We are not explicitly, as I said, right? It works on both EVPN and VXLAN. So VRF scaling is there.
Okay, so you might want to consider both.
Which one? Yeah, because the VRF, that, as I said, right, the VRF, we can take the next stop where either it will be the label be provided by the.
I mean on the overlay.
The overlay.
Overlay VRFs and overlay VNIs.
I didn't get you in because the verbs comes in the overlay. Yeah. So that is, as I said, right, overlay verbs are considered. Okay. So the underlay, it will be independent. It will be independent of, as I said earlier, it is independent of any encapsulation, MPLS, or you can have VNI, or you can have a, EVPN MPLS. So that is independent. So verb scaling is there. Scale convergence is a parameter. It is the verbs. It is there. You can read that. It is mentioned clearly.
Thank you.
Type 5, I'll take into consideration. In this, we cannot have a number of peers in this test. But currently, I'm handicapped in that. Why? Because the Ixia or the Spirent test center, right? You have to emulate it. that kind of emulation is not, or I can have a BGP peering. I can.
But I believe Ixia should follow you rather than the other way. So,
So that is a challenge I have. So I have to, this is, as Al said in the earlier, this is a lab setup. So you define, this is my topo, and this is as an overlay, as I said, right? It's overlay. We are looking into it. Underlay, we make it as a fixed payload, and this is a certain parameters we are done on the underlay, and overlay we are scaling it, and we are defining the parameter to do that. Type 5 thing, I definitely work in my lab, and I'll get back to you. The type 6 and 7, I said, right? I'll because I never tested on that. It's a relatively new thing. Then definitely I'll get back to coming as a separate draft for that. Let me go through it, because as I said, I have to confess I didn't test it. It's a relatively new one. So
you will look at type 5 for this.
yeah, I will look into the type 5 for this. Because since it's a need, I'll try to skews in that, Al.
Yeah.
Because it's a deployment, so I will try to. I mean, I'm not,
Sure.
I'll work towards it, because I have a commitment. I'll work towards it. Let me see to that how best I can excuse in that.
Great.
So that's it about this draft. So this, I'll ask you a question. Like, this is all tested based on the traffic.
Right.
With traffic, northbound, southbound, and bidirectional traffic.
Good. Okay.
So that's it. Comments and support. That's it. I'm done.
Great. Okay.
Thank you.
Thanks very much.
Thank you, Al.
You're welcome. We're all thanking each other like crazy here. Let's see. So we've reached item and completed item 5 on our agenda. The next one is from your chair acting as a participant, and my colleague Jim Utaro from AT&T Labs. I economized on my time here and did not prepare slides. Here's why. We've only got 2 things that we're trying to benchmark here in this multi-home DVPN scenario, and I'm going to flip ahead to what they are. We're going to do some throughput and other tests on Ethernet segment, which is this part of this figure right here, and this is obviously for and it's another test for EVPN. But then our next plan, and this was something that Jim was asking for, way back in Chicago. What about mass withdrawals? So I'm not sure I've got this right yet, but I'm sure I'm getting close. And Jim said, yeah, it's close enough to ship it. So so we've got procedures for both of those things in this draft. I really welcome sharp readers, folks with EVPN experience, to take a look at this and tell me where I messed up, because I'm sure I did. And we'd be happy to fix this thing up. But I think these are a little different than the kinds of things you've done, Sadine. So we might progress this as an individual draft. We might combine them at some point if it makes sense. I don't know. But let's get some comments on this to begin with. And that's take the mic. So because I'm sure Sarah's going to listen to the recording of this at some point.
Yeah, Sudhin here. So I have a question. So mass withdrawal, what you are looking at? Mass withdrawal is like when the link is down, so it is gonna withdraw. Tell that, hey, I'm send a type 1 withdrawal, and is to tell the remote P is like, hey, I'm withdrawing this.
Yeah.
So or the remote routers in VXLAN per se. So what are the parameters you are going to do it? Because you withdraw it, then the other P will take it as the active. The forwarder or the designated forwarder. So what are the parameters in this you are defining it? I'll go through the draft.
What would you like to see? I'm putty in your hands.
Okay, yeah. What is the actual deployment is like? Once it is their link flap happens, like the mass withdrawal, then it has to clean up the old entries. The forward next hop should point to immediate how fast it is pointing to the next router and reduce the flood.
Okay,
so the flood is a dangerous thing in the production network. So the longer the flood, withdraw it, clean up the, what all the cleanup, because the 1P is down, mass withdrawal 1P is down, the other one kicks in. So the mass withdrawal happens, so the forwarding table is cleaned up, and immediately it switches to the new one and starts relearning. So that is the delta. You have some, packet drops coming in and the relearning, so that, and which will cut down the flood.
Okay. All right. So I suggest you write that up in a comment.
Yeah,
and-
sure.
and
I'll write to that because I'll go through it because I think recently it came, right? But so I'll go through it.
Yeah. Very good. Thanks.
Thank you.
Yeah, I confess that we used even the extra day on draft submissions because that was the only day Jim and I could get together. So we stressed the end of the envelope to get this thing put together for you. But thanks for your comments, Sadim.
No problem. I need it.
Very good.
It's good.
Great. All right. So I'm going to make a quick note of that here.
Al, maybe one more thing you might want to consider is to test how the traffic is being spread among the two Ps.
How the traffic's being spread?
Yeah.
Yeah. Okay. Yeah. In fact, I'm fairly sure that I didn't do the throughput test in a 50-50 kind of split, where it could all be restored in the next step of the procedure. In other words, when let's say in this picture, when PE1 goes down and the traffic split across the ESI,
Yeah.
then you want to be able to restore all the traffic.
Yeah.
So you have to have that.
Yeah, but the question is
split.
also even before it goes down, right? How the traffic is being
Right.
delivered.
I meant to say something about that.
All right, okay. Cool.
Good. Thanks, Parag.
Thank you.
All right. Okay. Question mark. We'll find out. Okay. All right. All right, on to the next. So now we're in the continuing proposals. We did all of the EVPN stuff together, and two of those drafts were brand new, just to get everything EVPN done at once. So now we're looking at the updates for the back-to-back frame benchmark. This is where we. I'm going to stand up for a minute. This is the case where we're updating the RFC 2544 back-to-back frame benchmark. It is the benchmark where we try to measure the size of the buffer of the device in the very specific case where on a single port to single port relationship, the device under test can't transfer all the traffic. In other words, there's a limitation for 64 bytes, typically 64 octets or 128 octets, and those are basically cases where you can't get a single port to single port kind of connectivity. Now, in physical devices today, this is not an issue, but it's still an issue in the virtualized networking devices world. So that's a good reason to update this. So like I said, it's the 2544 update. We're testing the extent of data buffering in the device. The original procedure in 2544 was very concise. By that I mean really short and sweet. We're doing a lot more with it here now. So we ran some tests in 2017 under the OPNFV VSPerf project, and those indicated we needed some areas for refining this calculations. So besides calculating the number of back-to-back frames that we can launch into a device without loss, that's an indicator of the buffering that's available. And we're going to measure that in terms of all these different statistics. But as I was explaining to Barak during breakfast yesterday, some of the frames flow out of the device when you're sending them in because it's actually processing, it's live. So what we're doing is actually correcting the calculations based on the throughput, which has been measured as a prerequisite for this test. So we have this implied buffer time, which is the average number of back-to-back frames in the burst, divided by the actual, the theoretical frame rate. And then we have a corrected buffer time where we take away the frames that have been delivered during that time frame. And that's the implied buffer time times this ratio of the measured throughput and the maximum theoretical frame rate. So that factor should remove the frames that have been passed through the device as it's under test. So in version 3, we resolved all the open points about search algorithms. We're doing that on the basis of the Etsy spec that I showed you before. We have a new search algorithm there called binary search with loss verification. That'll be very helpful in our virtualized environment. I encourage you to take a look at that, and also the results that we presented on this during IETF 102. And the buffers are key to absorbing the transient interrupts that cause us problems when we're benchmarking our devices. If the buffers are large and forwarding is suspended, the buffers absorb that, and you have a loss-free environment. But you have more latency in your device too. So you got a trade-off between these two things, and you can't just throw it all into buffer. That's be a problem. So devices are going to be designed with some limited buffer. That's going to determine how much transient, or the extent of the transient interrupt duration that you can stand, and then this specification is how we're going to characterize that effective buffer size. So these two things are very well married in terms of what we've learned about this, the transient benchmarking world. So we're saying that you must use one of the two algorithms above, either straight binary search or binary search with loss verification, and that's where you repeat any test where you experience loss. Okay, so in the previous tests with the OVS vSwitch, in this phi to phi environment where we're just connecting up our test devices external, connecting up through physical ports, going in and out of the vSwitch, and really bidirectionally tested. We didn't see any transients in this case on the left here, phi to phi. But anytime we included virtual machines and the logical ports through the vSwitch, we saw lots of transients. And then our binary search with loss verification really paid off. It reduced the variation tremendously, sometimes about 100% of the variation was reduced. And in fact, we got much closer to the true resource limitations by testing that way. And that's incredibly important for determining the total cost of ownership. We've got two kinds of problems now, resource limitations and transients that come occasionally. And we want to characterize these things separately. We want to attack the tuning of these two problems separately. So we'll do that with long-term testing for the transients. So like I said, we observed the transients in any scenario with the VM. So what did we do next? We ran some tests with SRIOV. This is Intel's bypass technology. So now we've got no vSwitch, no logical ports inside. We got the vNICs there. And in a series of tests, this scenario using test PMD is running in the VM. Again, we saw very few transients. In fact, of trying this 4 or 5 times, this is the only case where we ran, let's see if I can do this with the pointer here. Is this going to work? Ooh, I thought I saw something there for a moment. There it is. There it is. Yeah, so we have all these iterations, and they're numbered there, right? And we start out at 100% of line rate, which is 10 gig in both of these cases. And you'll notice that, I mentioned this last time, actually the test device can't quite send at 10 gig. So we get these extended durations here. But at 50, it's good because we're doing a 10-second duration test, and that's what we get pretty much every time here. And notice at 75, it's not quite right either. But in any case, look at this. One time we tested at 50% of the max rate, basically 5 gigabit per second, right? At 64 octet frames. And one time we saw loss, another time we didn't. All the other times we saw no loss at 50. So this little transient that came along here could have fouled up our results in this test. That's the value of the binary search with loss verification. Okay, so then we got a lot more work to do, and it turns out that the that the throughput limit is way down here at the bottom. It's 50.391% of the rate, and that's where we get a solid 0. So, and the main point here is across all these trials, we didn't see hardly any transients. So what the hell's going on? we saw all these transients back here with the VMs, and my original conjecture, as I said here, I think, was that the VM was the one attracting the transients. Well, it turns out it's not. It's probably, oops, sorry about that. Actually, there's the answer right there. So the conjecture was wrong, and it's not the VM that's attracting these transients. It's something else. So here's a long list of things that it could be. The test PMD is configured with pretty large buffers. I already talked about that. So that could be smoothing the transients out. We're going to test some more with smaller buffers. It removes the LVS DBDK switch processes from the whole picture. So maybe those processes are interacting with the VM. Removes the logical interfaces and so forth. And we also connected up the VM with a different path join there, the VFIO PCI, to make SRIOV work. By the way, it took me a long time to get this SRIOV configuration going. I'm not sure why that was. It could have been a cockpit problem here, but I had some help with friends, and finally we got it going. And then we got these surprising results. So this is the most fun I've had in a couple of months. Anyway, so the next steps are, we've looked at this draft 3 or 4 times now. We've done some testing with it. It seems to be valuable. I'm asking for a working group adoption of this draft. Who's read the draft? Apparently nobody in the room. Okay. So we're going to have to ask this on the list if we ask it at all. And I will also ask then, please read and send your comments to the list. I'll discuss with Sarah the possibility of starting an adoption on this. But we have had comments in the past, and in fact, from the gentleman who prepared the slides that I'm going to present for him next. He was unable to join us today, Mr. Yoshiaki Ito. So, any comments or questions? Anybody excited to learn more about this? Seems not today, but that's okay. All right, good. Thank you for your attention. All right, so then moving right along. Okay, so Mr. Yoshiaki Ito prepared a set of slides for us, and we looked at most of these during our last meeting, so I'm going to cover some of these very quickly. This is the case in RC 8239. It was designed for data center switches and other data center devices. So now we're in the modern world where if you send in 100% rate on a single port here, you get it. There's no problem here with packet size or anything like that. This is the sort of today's world. The plan in 8239 was to just oversubscribe it
just
a little bit.
A short comment.
Yeah, sure.
There are many problems, so it's not that simple. No, seriously, like if you take a look on the, let's say, 100 gig switches today, it depends on the vendor. It might not be 100% right, even if you put only one port.
Really? Okay. Okay.
Definitely.
Well, this was the authors of 8239 imagined the case where if you don't have the luxury of failing to support port-to-port connectivity, then you have to go with this oversubscription thing. This is the case that they're trying to handle. So
I think it's very important to decouple actually what you assume or do not assume about the pipeline versus the buffers.
Okay.
So it must be clear.
That's a good point. I think there's a lot of good benchmarks in this RC 8239, but I think what we're headed for is a sort of a revision of this. And I encourage everybody to write down their ideas about how we can better understand the test configurations and so forth. Barak in particular, you're bringing a lot of expertise to the group today. I really appreciate it. Thank you. But let's cover this quickly. So in the case where you can handle the full 100% rate, the idea was to add 1% in an additional port. and then to measure the latency. And that's what Mr. Ito has done here. So as your as the buffer size increases with the oversubscription, suddenly you get some loss, and then the number of buffered frames before that happened was 24. So that relates to the latency. And he tried this with another case with 100% rate, and you can see that again, it's doing very well. It's basically saying 24 is the answer again, 24 frames, kind of consistent. But then he tries it with 3, and now it's 12 and 12 and 12. So that's sort of an interesting case that we ought to be looking at a little differently here.
I think that makes a lot of sense, right?
If it's 12 and 12, yeah. But this is the sum, I guess, for 24.
Oh,
that's right.
I see.
Yeah. He looked at each one of these streams separately. So this seems to be the linear case. You're right. All right. So now we've come to the new slides that Mr. Ito has shared with us. So he's now looking at this possibility. So he's saying we've got this buffer. All the frames are either going in the buffer or somehow getting out of port 4. And he says, since the test frame also flows to the receive port during transmission, it is not known whether all the test frames were accumulated in the buffer or not. So this is actually the kind of correction factor I was trying to put in for the single port-to-port case. So what does he say? He says, in phase 1, we're going to push a lot of frames into the DUT, and they're going to be stored in the buffer. And why is that true? Because we've got pause on. Pause means nothing's coming out. So we're filling the buffer, and then in phase 2 of the test, Mr. Ito proposes that we stop the pause. In other words, allow the traffic to flow. The traffic flows now, and now we count the received frames as the buffered frames. Makes sense. Let's see what happened. Go ahead.
To me, it makes partial sense because once you operate with pauses, for some vendors, it might change the architecture of the behavior of the buffer for particular priorities.
Okay.
So you might get some wrong results.
Well, I think we're sort of in experimental mode here, and Barak gives me a thumbs up on experimental mode. That would have been lost in the recording. Thank you, Barak. So we're going to learn things here that we haven't anticipated, maybe more complexities than are expressed in this diagram. So here's the test, and essentially what we learn here is the DUT latency plus pause time produces 10 frames for one set of flows, 9 and 9. And the answer is 28 now, not 36. So we've got a little different result from this different procedure. And I guess that's it. So, Mr. Ito, I hope you'll get a chance to listen to this recording and take this feedback further in your future testing, and perhaps we'll see a future procedure on this topic. Very useful. So any other questions, comments, Barak?
Just a question, like I like the previous method to push more like 2 ports to 1. I think this is very clean, and then you don't need to make any assumptions about what the behavior for PFC and not for PFC, and correlate some stuff around it. At least personally, I prefer this method.
Okay, and between these two, the 100%, the dual 100% and the 1% oversubscription, I mean, we got 2 different answers here. We got 24 and 48, because I guess this 1% really, I mean, there must be some buffer in this path that wasn't really getting filled by the 1% stream, and so I think that there's got to be some accounting for this. I mean, basically, we're discovering something about the device by running.
So it has to do a lot
tests.
with the internal architecture of the switch.
Yes.
so when you do one from one port and hundreds from the other port, again, it depends on how you implement the buffer, and then it might vary. So I think it's more consistent to have the same rates from
Okay.
both, but maybe it's interesting to test when it's not
Yeah.
the same thing. So
Okay. All right. Well, I think all three of these, there's three types of tests here that are all in 8239. So with more experience, we may be able to pare these down to the ones that make the most sense. In any case, thanks very much for that feedback. Anybody else comments on this work? I'm really glad that we haven't met Mr. Ito in person, but hopefully he'll be able to join us in a future meeting remotely. So very, very kind of him to do this work. Okay, thanks everybody. So let's see, what are we on to next? Let's see. So Ole, it is now your chance to represent some drafts here. So Mr. Ole Trone is representing Vratko Pollock and Maciek Konstantinowicz on two brand new drafts that showed up in the group. Actually, they didn't show up in the group. You'll notice that these are brand new drafts, two authors, but they forgot to include Bmwg someplace in the file name. So that's feedback number one. I'd like to see them republish this with Bmwg in the name so it shows up in the rest of our stuff.
That is indeed good feedback, and I'll take that back to them. So I'm purely standing here trying to represent Maciek and Vratko. I'm not smart enough to take any questions, so please send those to the list. But any comments, you can make them here, and they will make it into the minutes. So these are two drafts that has come out of performance testing of FDIO VPP, which is an open source project doing a software data plane. I'm a contributor on VPP, but I'm not very good at testing, so please be kind to me. So what they're proposing, they have two small drafts. They're very short. Anyone read them yet? You probably haven't seen them since they didn't make it to the working group filters in the data tracker.
I did add them to the agenda,
Yeah.
the text agenda. So
Yeah.
if folks at least read that, they had a chance of finding them.
Yeah. So it's about search algorithms finding the rate for testing. One is for deterministic systems. So there's multiple loss ratio search for packet throughput. New search algorithm, and it finds the maximum receive rate quite quickly. And it's being used in the CSIT testing project for VPP. That's all open source, so you can go and look at that. And I think there's some reasonably good description of the algorithm in the draft. Then unfortunately, we don't have deterministic systems in these new software-based routers with where it's all runs in software. You can sort of make it reasonably deterministic, but as soon as you add VMs and stuff, it becomes quite hard, and even modern CPUs are really not deterministic anymore. So then they have this probabilistic loss ratio search that uses, say, distribution to try to map this, especially for soak tests and things that take time, so they allow for a deviation without dropping, where you can't expect a system to be deterministic over hours or days of testing. So we certainly seen this on all this NFV testing that we do for VPP, that there is some variability there that it's hard to account for, and so we modify these tests. I think most of these drafts are proposing updates to 2544.
Right.
And I would expect them, this is just revision 00, but at some point I'm sure they would like for these to be adopted in this working group and then taken as, I don't know if you have plans for BISing 2544, but.
Well, the way, that's a good question, and I'll be glad to address that, Ole. What we've been doing is sort of updating parts of it as we learn new things that need to be improved. So, for example, the loss, the long-term loss ratio testing here, that's actually that's kind of a thing that isn't actually part of 2544 right now. I think the longest sort of the longest duration testing we talk about there is in the verification stage of about 60 seconds, something like that. On the other hand, in the industry, we've talked about long-term testing. And so this may be, kind of an area where we are simply expanding 2544, not replacing something that's there. Now, we talk about a lot of different search algorithms in RFC 2544, linear and binary search. And I mentioned that in the ETSI now published specification, test 009, we have a new search algorithm there that's designed to be robust to these transients and the non-deterministic problems that we're talking about measuring here in the long term. And to some extent, the other draft, the ML research search algorithm, that has that's trying to uncover multiple thresholds within a single search suite.
Right, with different sets of packet loss ratios. Yes.
Yeah, that's
yes,
right.
yeah.
That's right. So, but that may benefit as well from the addition of the verification phase that we've done in the binary search. So there's lots of good interaction here, and I think that ultimately, if we may continue to update 2544 on a piecewise basis, and then at some point, declare a flag day and update the whole thing, replace it with a full BIS.
Right.
So I think that may be.
And I mean, all of this has come out of this need we had for in the VPP project. So per commit to have the test framework detect if you had a performance drop or not.
Right.
And of course, that became quite hard when you have an intermonistic loss ratio. So that's where this work comes out of. And I would imagine it would improve all the time, and they will gain more as they gain more experience, and hopefully they will put that in this draft as well.
Very good.
Super. Thank you.
Thank you. Thank you very much. This is one thing we've learned in this process is there are really three kinds of roles of search algorithms. There's the ones that basically spawn this kind of search in the FDIO CSIT, where they're sometimes two or three times a day. They're testing a regression of new patches in the system, and effectively they are expecting the same result. So they want to get through this testing as quickly as they can and discover these new levels of multiple levels of loss ratio and throughput. There's other kinds of testing where we sort of do it really experimentally, and we have no idea what the answers should be. And that's where binary search with loss verification, just searching for a single threshold, is one where you spend lots of time dedicated to that. And then there's other testing where you may be searching for a non-zero loss threshold. This covers that, but it also works differently in terms of getting feedback from the test results, which is more than just was there loss or not. The key thing that they're pulling out here is very often the maximum frame rate that's revealed on the receive side that should be put into your testing search algorithm, which is exactly what they've done here. When you look at the results, it's pretty obvious that that's what you should do. In fact, if you go back and look at one of the slides I showed there before, it's painfully obvious there. So unfortunately, for a lot of people, the iterations, the trials of the search algorithm are kind of hidden inside like a turnkey operation, and you get the result at the end, and most people are happy with that. But when you're tweaking the search algorithms, you want to look at the whole thing, and that's when you begin to understand how they're really working in our world with transients and sometimes lack of determinism. So, Oli, thanks very much for presenting, and Maciek and Vreco, thanks for bringing this work to us. I encourage everybody to. Has anybody read the drafts? That was really aspirational. Oh, somebody has their hand up. Thank you. Well, they're short. They intend to expand them, and they intend to show up in person at the sort of the next session. So not the next session, but the next IETF. So that will be good. We'll have a real chance to go over them then. So anyway, put this on your reading list. Both of these are very fundamental to our work. Okay, so then on to the next. So the next thing in our list is a liaison. It was written from ITUT Study Group 12 to IETF, IPPM, and many other standards bodies. But the main thing that I wanted to raise to everyone here is the fact that these folks are all trying to measure internet access performance. And because many standards bodies are involved, it's an attempt to harmonize the methods of measurement that will be used in the future. Now, don't do that. Here it is. If you open this liaison statement, and you have a link to it right there, what we have is sort of a description of the progress of ITUT Study Group 12, question 17 on packet performance, and their work in conjunction with the ETSI Speech and Multimedia Transmission Quality Committee, that's ETSI STQ. And what they're basically doing is entering into an evaluation plan where different methods of measurement for measuring internet access speed and latency and other performance characteristics are all going to be compared objectively in the laboratory. As far as we know, this has never been done. If calibrations have existed before like this, they have not been shared publicly. So our method is to use a calibration system, establishing a ground truth. And this has relevance in our work. We've never actually done this here, as far as I know. In other words, we're searching around for the capacity of switches and routers and so forth, but we've never put our measurement systems up against a device under test where we think we know what the capacity is. So now there's relevance to us too, not just in that category of calibration, but in this new world where I've drawn a nice picture here of a house and a phone and a very big blue access capacity pipe. And you'll notice that it's 4 digits and the megabits. So we're talking about something in the gigabit per second range. And this is what's happening in our world today. Comcast, about 2 weeks ago, Comcast, a big cable TV and internet provider in the US, they announced that they have gigabit access service available to 60 million homes. When I first got involved with voice over cable television work, all of the cable TV suppliers in the United States offered television service to 60 million homes. Now we're talking about one multiple service operator and gigabit internet access, same number of homes roughly 25 years later. That's a huge change. Now, what does that mean for the characterization world? Well, in the benchmarking techniques that we've been using here, we've been measuring rates like that easily. But we've been doing it in the lab where we have, very controlled circumstances. And fortunately now, we have new robust search algorithms coming on the scene. We've been driven to that because some of the devices under test are less reliable for us. The general purpose computing platforms where we have virtualized network functions, they have interrupts that show up every once in a while. And those interrupts can affect our searches if we're not careful, if we're not doing some kind of verification in the search process. So we're actually making our systems more robust that they could be applied in the production environment. I'm going to come back to that point a little later, but today's access test methods like UCLA-speedtest.net and the things that are being used in Europe, Aladdin IT in Austria, Zavaco, which is basically the same software in Germany. Assume the same system is going to show up in Finland. They're all using N times TCP connections to measure tens of megabits, maybe even hundreds of megabits in a carrier aggregation kind of scenario. But are they going to be able to measure gigabit per second accurately? I mean, right now they're using 3 or 4 connections, something like that. I mean, are they going to continue to add to the number of connections and have reliable results? I kind of think the answer is no. And our laboratory characterization is going to show that. So what we're basically doing in the laboratory is we're taking this picture with the house and the phone. So we're both fixed and mobile. That's our scope. And we're saying that we're going to measure just this access pipe to this measurement system that I've depicted there as the host with the storage. And we're idealizing that at first. We're replacing it with this laboratory setup, and we have the PHY to PHY, physical port to physical port, and vSwitch, and our test device is connected to that. It's isolated from the test device. But for the first time, we're introducing a Q discipline, which is typically a token bucket filter, and it operates on egress of the device. So I'm showing that there, and kind of operating with the physical ports. And so now we can set calibrated levels of capacity that the token bucket will allow, and we blindly launch our search algorithms, and we say, do you find the right answer? And if we launch 3, 4, 5, 6, 7, 8, 9 TCP connections, do they find the right answer? And if we get other methods of measurement that are suggested, like the IPPM model-based metrics, does that find the right answer? So we're basically contriving a little bit of a bake-off here with very fixed circumstances, and we're going to find out in this phase 1 of the evaluation who gets the right answer here, who measures the calibrated path accurately. So we've already started to do this. We've started it with our benchmarking with the UDP packets. We did 64 and 15, 18 packet sizes. We briefly, the results said that we were able to find the capacity limits doing that testing with the binary search with loss verification. The best performance, closest to the right answer, the calibrated value, was using the full MTU packets of 15, 18. In this laboratory setup, I still haven't got iPerf working. Who's familiar with iPerf? Quite a few. It's capable of launching the the multiple TCP connections, but there's other versions of this floating around too. There's an iPerf 3 now, which supposedly works better. Also NetPerf and some other things in Perf Sonar probably out there, right, Bill? And things that have been used in internet too. So there's lots of possibilities for things that can make these measurements, including Matt Mathis's code, which implements most of the model-based metrics RFC, not all of it, but a good portion of it. So my plan is to get as many of these software-based traffic generator and measurement devices implemented as possible in this blue box here, and we'll basically in this phase 1 have this runoff, and we'll compare the results. And what I expect to see is that some of them will not measure the full bandwidth. Some will be very confused by this, and that's an important thing to quantify, because at the end of the day, people are going to be measuring access capacity. Regulators are going to be interested in that, because they're going to want us to prove that if we're selling a gigabit per second service, that we're actually providing a gigabit per second service. But note that the scope of that is really just this access pipe, and that makes a lot of sense. The user traffic is going to go to either an edge device like is shown here, or maybe somewhere close by in a CDN or a video server. But when you've got a video download, 4K video download, 25 megabits per second. It's not gigabit. So beyond the access pipe, after you've proven that the access pipe can handle a gigabit per second, now you've got something else to test in the distribution network. You want to test from the end of the access pipe to the video server, is 25 megabit per second available there? It's not a gigabit. And that's very friendly for testing your distribution network. You don't want to be running a gigabit around to 20, 30 test sites in a full mesh. That would be a very non-economical solution to the testing problem. So Mike, you're up here.
Oh, you got my head spinning. This is fascinating work. I was just going to ask the next to the last bullet, and you covered it a little bit, but I didn't quite catch. Can you say what that meant?
Oh, well, there's a tool called iPerf, and it's been around for a while. It's actually in version 3 now. And I'm trying to get iPerf working in this single host.
I may have asked the wrong
environment.
question. Not the last bullet, but the second to the last.
The second
one?
to last. Okay.
The UDP cap limits, best perf.
Yeah, I've actually got a
that one.
slide that helps with that.
Okay.
So you're a great straight man for this. Stay up in the mic because you may have questions. All right. So remember, I said that in the green dots there, that's where we're introducing the token bucket filters, and so we're gonna set that token bucket to 100 megabits per second, and we're also going to add 4 milliseconds latency. We need to measure latency at the same time we're doing capacity testing. A lot of the access systems today don't do that. What do? They measure TCP flooded throughput, wasting tons of packets, just trying to get the maximum throughput through. And then they turn all that stuff off and they measure latency with ping. So they don't ever see the full buffers that you've just completely occupied while you're measuring the maximum throughput. And now you're not going to see the true latency that matters here. And by the way, these future services with gigabit capacity, they also have strong demands on latency. I mean, that's what 5G is all about, right? They're extremely high bandwidths and extremely low latencies to support applications like virtual reality. Virtual reality works pretty good if you have a latency of about 5 milliseconds. Raise that up into the 20s and 30s, and now you've got nausea. And the effect of nausea is creating, if you're walking down the street, you're creating now what we call a sidewalk pizza. All your lunch comes out. So you don't want that to happen. There's clear physiological limits on providing some of these applications. So we ran a test with 100 megabits per second, and the UDP capacity that was measured with our test with the binary search with loss verification, 100.5 megabits, pretty close. We tried the same thing at 200 megabits per second, 201. I'm actually beginning to think that I need to check the timing between these two devices in the lab. If they're not both synchronized like to the same NTP server, or if somebody overlooked this in their setup and they've got a huge time offset between them, this little bit needs to be sorted out, and that could easily explain this, this 0.5 megabit per second. Now, another part of this, though, is that search algorithms we use have a tolerance. We don't try to get it down to the exact bit per second. We allow a sort of a level of uncertainty and ending the search when we've reached a point within that tolerance. So basically, in classic binary search, you're trying to find a single value in the search range. In benchmarking searching, you're trying to find a level of offered load where there's zero loss, and then above it, a level of offered load where there is packet loss. So you really need a pair of things to end your search, and the distance between those two offered load levels is the tolerance. You have to get within the allowed tolerance for zero loss and loss above it. So that's the sort of the ending criteria for the binary search. Now, both of these values are well within that tolerance. So in fact, it may well be that if I tighten the tolerance down even further, these are going to improve. So we're not sort of demanded here to participate in the liaison reply, but we can if we want. In IPPM, we're assembling a group of people that are interested in working on a liaison reply. So far, Doug has volunteered, and my colleague Ignacio from Argentina, he's also volunteered his team to work on the liaison reply. And we're also asking people to join the effort, to contribute methods of measurement, to perform calibration in labs other than the one that I'm currently using now. It's part of the OPNFV VSPerf project to make access technologies available for the phase 2 of the testing. So in other words, if you have a fiber passive optical network that you would be willing to let us test in the laboratory, that would be cool. If you have a connected scenario for your mobile devices, that would be cool. So looking ahead here to phase 2, there's more work to do. We want to really see how these things work in the real access environment. So I'll pause there for comments. And if you're going to say something, Sudhin, hop up at the mic. Yeah.
Yeah, Sudhin here. So you said for the calibration, right, for the DUT, but the calibration normally we do for the testing and measuring equipments, like you say, this is say 1 kilo means, how do you define 1 kilo? So there is a standard thing in SI unit, this is based on this is called as 1 kilo. Then you based on this testing equipment for 1 kilo, what is that? Then we rate. So in the test, normally the calibration is done for all the testing and measuring equipments. The DUT is normally we don't do it.
So you don't do it in the DUT.
Then we use RT or the router tester or the XIA or the Spirent or whatever
Right.
the tools available to measure what is the degree of or the delta based on the parameters we are doing it. So I didn't follow what DUT calibration. So
the typical, as I understand it, I'll use the pointer here. The test device calibrations that we've done both in our laboratory and in the IPPM work have been a simple sort of cross connect loop back here, maybe just a cross connect cable, and with that, you're able to tell whether your test device is able to, for example, generate all the traffic necessary to fill up a 10 gigabit per second link. And I mean, you don't have the timing problems that are typical because your test device is using the same clock on transmit and receive. But you want to know that, for example, that you're filling the 10 gigabit per second pipe when you think you are. And as I pointed out before with those test durations, the software traffic generator that we're using isn't quite measuring up to that. So that's a kind of a test on the calibration itself right there. So I mean, it may be too strong to say that in the benchmarking world we haven't done calibrations because we have, but what we're doing now is calibrating against a range of target values. So I think that's a good clarification, Sudhin. I thank you for mentioning the kinds of calibration that are going on today.
Okay, and one more question is like you said, I mean the pipe, right? Say gigabit Ethernet internet. That means normally the provider will give gigabit Ethernet to the first hop router because they don't have that much, because the bandwidth is shared. So we have a contention like 1:20 or 1:200 like that. Because the last from the first hop router to the network, all the users will be sharing a common pipe. So you won't be getting a gigabit Ethernet. If you are going to the Google server, you won't be getting that. So they always mention like the last mile. Okay, you have that pipe.
Right.
Then after that, it as you said, like 25 megabits to the CDN network or that. So that will be, testing, that will be complicated, right? Because you cannot simulate all these things in the lab, and we have a confined area, or we have to use emulators to do that.
Well, there are some laboratories that have that capability. They're not in this current phase 1 scenario where we're doing this calibration, but labs are out there that exist that have this. And we're even in the production environment where there's things going on, we're going to need to demonstrate that at least some minimum rate is achieved. And very often the specifications have some variation in them, like they say up to a gigabit, and then maybe the minimum then they will give in some lesser value. So I mean, those are the kinds of things that have to be verified with a short test in the field.
Then you have to be a clear demarcation, right?
Oh yeah.
Because okay, this is from this to this point A to point B, from B to C, or the node B to node C. You don't have that because it will be oversubscribed or it will be content.
Well, there are ways to test this where, in fact, you're truly searching for the available bandwidth. And if it's dependent on other users, like the mobile environment typically is, then you're going to be searching over a wider range. But the first thing you should try is the rate that that you've been guaranteed, or the rate that is part of your service contract. So that may be a very short test where you say, is this rate available or not? And then if you need to search around because the access infrastructure is shared, then that's going to take a little longer.
Yeah,
But
it'll be take
there's
longer.
certainly ways to do this.
Yeah, because it takes a longer time, and it requires the complexity in the testing to have this much of slots available or like that. Because
That's right. And obviously mobile is a lot of dynamicism.
correct. It's pretty difficult. That's what I think.
Okay.
Yeah, thank you.
Good, thank you.
Welcome back, Deutsche Telekom. This is useful for internal testing, I think, and UDP will certainly give better results than TCP. But when it comes to the regulator, they want us to show that the customer actually get the bandwidth we advertise, including all the TCP and CDN stuff. And this is a problem.
Well, I would challenge that a little bit, because the BEREC regulation, I mean, you're DT, right? The BEREC regulations specifically talk about IP capacity. Now their testing tools are using TCP.
Yeah.
But the regulation, which incidentally Rudiger Geib and I have talked about at some length, they're on the right target for the capacity of the IP payloads. Now they're going to have to do some kind of correction factor with the systems that they've just chosen, which do use TCP. And another factor that I didn't mention here is that obviously IETF is working on the QUIC protocol.
Yeah.
And that's a thing that's changed over the last 5 years. I mean, 5 years ago, we could basically trust almost any internet access was the bottleneck. Now that picture has changed with this introduction here.
Will get
Also,
interesting
TCP
anyway.
was the dominant transport. That's changing now. So lots of things have changed. We're pointing to UDP as actually a more representative thing for this sort of future world, and I think it's going to be simpler to test with.
Yeah, especially as some CPEs prioritize TCP-X, for example, to account for some queuing issues.
Right, that's right. Yeah, very good. Thanks. Give your name to our note taker here so that he can pick it up. Very good. So we're nearing the end of the session. I think that's it for this. Did I have something else? Oh no, that's just the notes here. Okay. So let's go back to. Go back to the agenda. So we have a few minutes left here at the end. Would anybody else like to bring up any other business, any other topic which you might think about benchmarking in the future?
Per what we're discussing this breakfast, I consider maybe to extend the work that has been done on this RFC that you presented before. One important factor of the buffering and the performance behavior of switches today is how fair can they apply the SLAs across multiple ports, priorities, flows, etc. So I think we see a lot of interest about that in the industry.
Mm-hmm.
So I think it would be interesting to add some drafts about it.
So let's see here. Let me see if I can get that up. It's not that one. Is it this one? Nope. It's this one. So you're talking about fairness.
Yeah, between the ports.
Between the two ports, right? And this is the oh shoot. So this is a test that would augment the set of things that we've got in RFC 8239.
So it's similar in a way, but it's not the same.
Yeah.
So it's pretty close, but what you have to report is different, and some of the methodologies are different, but it's in the same lines.
and with different QoS levels and so forth?
Potentially.
Yeah.
But to start with, even without certificate QS.
Okay. Very good. Thanks for that suggestion. I hope you're, I mean, you've offered a tremendous number of excellent comments today, Barack. I hope you're willing to help us out with this a little bit. That would be great. Thank you. Okay, any other business? Any other topics people would like to raise? Ignace, you get the last word here. Anything from you?
Nothing special. So actually, one question, Mark, that you have. So you said.
Want to take the mic?
Right.
Yeah, you can use this one.
So, right. So you said there's industry interest. So I presume that's from your side too. Are you willing to bring in the documents and work on that?
Sorry, can you, what's the question is?
About your proposal about the fairness
Yeah.
benchmarking.
Yeah.
So are you interested and are you willing to bring in the documents for
I
that?
am interested. I need to make sure that I have the right time for that, but I am interested in that. I cannot commit at this point, but I am interested.
Maybe you can find some other folks here who are willing to help you, get you
If
started.
anyone is interested, please let me know.
Yeah, that would,
So
that's good.
as you mentioned that there is industry interest, so therefore I would assume that's more than just say, your interest, right?
Right.
So if you could coordinate with other interested parties and bring in that as a work, that would definitely be fine.
Sure. And again, if anyone here is interested, please let me know.
Sure. In fact, Ignace, can you suggest any mailing lists where Barack might make his proposal beyond the Bmwg and possibly bring some folks in that aren't currently working with us?
So one general suggestion is that IETF should be a little bit more outreaching to the actual field to see how things are being used and what are the problems there. So those are not necessarily mailing lists, but actually specific forums, industry forums, like right now, Apricot, probably the three largest ones in the three geographical areas, then say country-specific or vertical-specific gatherings. Those are happening all year round. Pretty much every week you have one or other event happening somewhere. But if you start right now, Apricot, that would be free large user bases where you can get a large amount of feedback of what is relevant, what is needed. At the same time, present to them the methodology which you are doing here. Let's face the reality. Many of the topics that are being discussed here at IETF, they are not known outside of the IETF. And that simply needs some, call it marketing.
Yeah.
And you will, with this, you will get relevant feedback from the field.
Very good. Well, thanks for that comment. I think that's relevant input to all of us. That if we can take some time and make a visit to one of the network operator forums, it's always valuable feedback there. Mike?
Mike Ackerman, I may have missed something. On the agenda was next generation firewall performance testing.
Yeah.
Was
the
that
first thing we
contained
did.
in the first item?
That was the first item. Yeah.
Okay. Then I'm interested in that.
Okay.
And I thought it was going to be a separate subject, so I didn't say anything at that time.
All right. Okay.
So do I talk to you later or?
Well, no, I would suggest, I mean, what you're doing right now is basically indicating support for the work.
Okay.
What I'm going to ask you to do though is read the internet draft and
Okay.
maybe provide some comments on the list. So we got support from two people face to face and three.
Okay.
So yeah, so now I've got you, Sidine, and Barack and Mike have all indicated support for that.
I finally get to work with Sudine. All right.
Yes, that's good. Well, actually, this is Sudine's doing all the EVPN sorts of things. This is the next generation firewall stuff. Yeah.
Okay.
So Samaresh and actually Karsten Rosenhobel and Balaraja, I forget his last name.
Okay. Thank you for clarifying that.
Yeah, sure. No, thank you. Thank you for jumping in. Very good. So we did get good support for that today, and I think we may be able to move that into working group adoption, or basically into the successful adoption. Oh, okay. All right, very good. Okay, folks, we're right on our 2-hour ending time. So I thank you for your attendance. If anybody hasn't signed the blue sheet, please sign it. And the guys in the back, please locate it so that, did you sign it, sir? Yeah, okay, very good. All right, thanks for your attention today. I really appreciate it. It was a good session and a fairly successful one. So have a good next session. I think we got 20 minutes off now and a cup of coffee and then lunch. Thanks, everybody.
Thank you, Al.
Thanks, Aaron. That was good.
Good.
I got some stomach. I wanted to show you something.
Yeah.
This is what we're selling to a whole bunch of customers. This is our little one tester.
Wow.
And you basically plug it into like a home router.
No kidding.
And it's good for, it's got a 1 gig port.
Yeah.
It's good for greater than, it can do like 2 gig of traffic.
No kidding.
So we're doing iPark, we can do every other test. And I'm wondering, maybe we can use it in your study.
That would be
I
cool.
can send you pictures.
Well,
You can
I don't.
kinda coordinate.
Yeah, I don't know that